In this slide, we will talk about the error against the true value. That's why we call it true error. And basically, it's the relationship between the exact or true result and the approximation result. And we can simply write the true value as we have an approximation from numerical approach, for example, and an error of it. So from here we can find the true value, or we can to be able to find the true value, we simply sum the approximation and the error value. And because we want to find the true value here, this error is actually called true error. And if we isolate this true error, we find it as the difference between the true value and approximation. And we can define this true error as, in short, ET. And this is equivalent to true value minus approximate value. And the true value can be defined, for example, as x in a symbolic term, and the approximate value, because it's also x actually, and we define it as x tilde, let's say. The sign at top of it defines that it is an approximation. So we can maybe say that this defines approximation. We will use this in the following notes and slides. Approximation. That's why I wanted to define this in here. And this subscript T here, the ET, designates the true error. So this is a good definition of error actually, but there is a shortcoming of this error definition because it doesn't take account the order of magnitude. That means that we can have different magnitudes, such as one value can be 1 and the other one can be 1,000, and the difference between them is too much, but the true error can be in the same magnitudes for these kind of values, and it can be a problem to evaluate them. So, for example, an error of a centimeter is much more significant if we are measuring a rivet rather than a bridge. And we will talk about these as an example in the following slides as well. But to be able to solve this issue of magnitude difference, we actually use a normalization, and we will show this in the following slide. Here we define another error calculation, true fractional relative error, and simply we divide the true error to the actual or true value to have a normalized error value. And so for that we can write the true fractional relative error as true error divided by true value. And in here we already defined in the previous slide that this true error is ET, and it is the true value. We said that it's x minus x tilde, the approximate value, and this true value here is x. So basically it is x minus x tilde divided by x. And we also multiply this with 100 and we find the percentage relative error, and we call it true percent relative error. And we show this as epsilon t, and this is equivalent to true error divided by true value times 100%. Or if we want to show this in symbols, epsilon t is equivalent to et divided by x times 100. And we know that et is x minus x tilde. So this will be the formulation that we want to use while calculating the error and evaluating it.